So today we will talk about update strategy. So we will make a step back in regard of the conference we just had before. We'll take less technical, but more about how you can implement such type of firmware update and the different way you can do it. I'm Pierre Gal, head of product for the embedded kit, where we are developing a solution, software solution for implementing industrial grade and secured solution firmware for our customer. And today I'm with Josef. Do you have a microphone? Can we have an additional microphone?
It's okay.
Take ours.
Thanks a lot.
Because I just have a very short slide. Usually it's my turn to break things, because that's actually what I do for work. So I'm head of developer relations, which usually I say is about making developers inside and outside of the company happy by making them achieve their goals, which in reality usually means that people tell me, try this new thing, and then I break it. Just like you would with the bomb almost. So that's what I do. I know your feelings. And yeah, Pierre will take us away. I will just fill in one very hot spot, which is relevant for me. And besides that, he really is the guy that runs the show for you today.
Thank you, Josef. So let's start with the famous why. Why do you need to perform firmware update? I think I don't really need to re-explain that, but I really would like to highlight the fact. I don't know why there is no slide. Please. Yeah, so firmware update is vital. Even if 5-10 years ago firmware update was something that could be interesting, today that becomes a vital feature for your equipment. We have identified the 4 main reasons why doing firmware update, but fixing first. Everybody's here, at least who are doing software, probably already have done a bug. So even in production, even if you spend days, weeks to test your system, there is always a risk to have bug included into your product. So being able to deploy a firmware update means being able to deploy a bug fixing. That's more or less the same for the optimization. You have potentially an equipment that will change in the time, and you may need to implement better performance for your Ethernet driver, for your flash driver. And so that's also a key topic when you are developing a product. Another interesting why of developing firmware update is about new features. More and more OEMs are packaging additional features with dedicated business model to deploy a new feature if you pay for this one, or enable a feature for any different type of customers. So implement new features, deploy new features is something that also could be important for firmware update. But out of these 3, why are not the most important. The only one that is important today is about vulnerability management. New regulation, Cyber Resilience Act, lot of issue in cybersecurity. Tomorrow, 100% of OEM will need to have a vulnerability management system. That means identify the vulnerabilities, communicate about that, but also provide patches to fix it. So that means it's by the end of the year for having the official CRA deployed, and everybody will have 3 years to deploy everything on the market. So vulnerability management is today the key topic why you need to have a firmware update. I'll stop about the why, and if anybody has additional say today, we'll be happy to discuss about that after the call. We will now enter into this update strategy. We will go through 4 different aspects, and then you will see that you can mix all of these aspects to create your own strategy in regard of your exact needs. Let's start with how to deliver. Just before, we have seen that a lot of people are working with remote delivering of the updates. This is definitely something that makes sense. It can be done through a dedicated IoT platform, device management, firmware update management platform. It's all the same word to explain that you need to connect your equipment, you need to deliver the firmware or a binary to your equipment. So it becomes something which is important, but that's not the only possibilities. But let's focus a little bit more on remotely update. You will have a global fleet management solution, so that means you can deploy your firmware in a row, in a bulk action for all your fleet or part of your fleet, instead of needing to manage one by one if you are in a local update solution. So it's quite efficient. You can implement and develop some additional features on top of the remote update. So as soon as you start to have your fleet management, your device management system, you are also able to get back some logs, to make remote configuration. So having this first step of communicating with your device from your firmware update could also open new type of feature for your system. And from a pure money perspective, it costs definitely less to deploy on a global fleet than if you have to move individually on all your different equipment. There is some different business models, some different way to deliver. In some, and more particularly in the B2C area, sometimes customers are doing manually this local update, but as soon as we are in a B2B model, you will have to need an operational team that will go on every point where your equipment are set up, and it costs for you OEM or for your customer that are deploying the solution on the field. Remote updates also bring a lot of cons, a lot of consequences. The first one is about cybersecurity. You are opening a channel of communication between your device and the cloud, so it could occur a lot of issues with cybersecurity. So please, if you are doing that in the right way, think about how I can identify my device, mutual authentication, certificate-based authentication. There is 100, and we can spend hours talking about that. Just think about, I communicate, I am through this internet world, so I need to be really carefully with that. You also need a robustness approach and methodology. You could not just say, okay, I deploy and hope everything will went well. Even if you are at 0.1% of failure, if you have a fleet of 100,000 devices, that means a lot of customers unsatisfied, a lot of action to take, and a lot of cost potentially to fix all of these issues. So robustness is a key topic when you are working remotely. And it will need for you some dedicated skills, because maybe you are specialized in electronic development, embedded firmware development, but you will have to start thinking about communication, cloud, connectivity, cybersecurity. So it could also open the door to a complex world that you will have to manage directly with your team, with the right partners, or with the right solution, but that's something that you have to take into account. There is a lot of skills as soon as you're starting to talk with the cloud. Small focus on local updates. There is less and less solution, but there are some constraints, products that need that. Implementation of this type of update system is usually simpler because you can be less robust, because potentially your operator is in front of your device and can reduce the operation if something went wrong. So could be easier to implement. As I said before, mass update deployment costs a lot because you need to move to your equipment, and you have no fleet management global overview of your fleet, so I don't know if patches, if version have been applied correctly to all of my equipment. So this is the first topic, remote update, local update. Then let's continue with what you want to update. In fact, there is different way and size of package you can deploy. You can imagine to deploy the entire firmware. If you're in a microcontroller, could be a small package, could be okay to go through the GSM network, could not cost too much. But if you are on a Linux operating system, an entire image could be 100 megabytes. So that's easier because you have to deploy a full firmware, but larger size, longer update, could cost more, there is more risk of corruption. You have to put in place some stuff to be sure that it will went well. The second level is more at partition level, even if partition level on an MCU is quite different. I'm focusing maybe a little bit more on Linux, but you reduce the size. You can separate your kernel, your root file system, your application partition, and start having a lifecycle management of your different subparts of the system, and say, okay, I would like to deploy my application without deploying my entire operating system. So size could remain large, but it's smaller. You start to have dependency manager. My application depends on a package that is in my kernel. I should be able to ensure that everything will work in every condition. If you have incremental update and multiple update on top of the previous version, you have to be sure that you are doing correctly your version management. And at the end, you can go through the, I said files, but it could be also binary diff into your system. So it's the smallest piece of update you can imagine. It's really optimized for transfer, costs less, but you really have to be careful with dependency management, with which version is could be deployed on which version of your system. So you really have to be careful with that, and it could cause some issue with, for example, secure boot. I will get a little bit more about secure boot, but if you start to implement small update, you will have to ensure that this small update is authentified by your system if you have a full chain of trust for the secure boot. I continue. So we have seen how we deploy, we have seen what we deploy. Now we need to talk about the robustness of the system, because having an update system means robustness. You can for sure use this first line, no backup. Install update, you remove the previous version in the same time, you overwrite it. It's probably the easiest way to implement such type, but definitely not recommended. It's right here because it's part of the option. Main issue, no rollback possible. That meaning if something occurs not as expected, you can have no more device available on the field. It's an option that is only valid if you are doing local update, and even in this use case, you need to be sure that you are able to restart an update operation. So definitely not what we recommend, but it's part of the ecosystem. The second strategy is about having a golden image. What is a golden image? It's like an hard-coded version of your operating system, application, firmware, a big bootloader that is able, at least a piece of software that is able to at least redeploy a new version. So that means this golden image is in read-only in your system. You will never change it. It will be reliable, and it will bring the possibility, if anything works not as expected during an operation of update, to do it again and do it again. So that's more interesting. You have to be sure that this golden image is very well tested, because if you have a bug in this golden image, you could more or less not be able to update it. That means from a vulnerability point of view, that could be also an issue, because maybe you will have a vulnerability into your golden image. That's not perfect. It could be interesting to, because it could also limit the size of flash which is needed. We will see after with the AB partitioning that you split your flash in two parts, and it costs a lot of flash. In the golden image, you can imagine to do something smaller. Yeah. One key point, one key problem you can have is about long-term compatibility. If you are talking about a remote update, you will probably have a certificate that you will use to authentify your device into your cloud platform. It will be probably certificate-based, but your certificate have a limit of time. So you need to be sure that your certificate has a longer period of validity enough to be able to connect to your server even in 10 years, 15 years. What is the lifetime of your product? That could bring some issues. So maybe you will have to build something that will help you to renew this certificate. And that could bring complexity. So be careful with that. And the warning we raise also here is about failed update. What's happened if there is a fail? What's happened if there is a failing loop? You have a risk that you have no backup. That means the operation of update should work at the end. When you are in a AB partitioning, which is the last model I will present, you will get back to the previous version. So AB partitioning, for those who don't know, you split your flash, you have the A version, the B version, could be A and B for the kernel, A and B for the rootfs, A and B for your application, A and B for your data and configuration, and then, while you are running on the A partition, you will update the B partition. Start to boot on this B partition. If everything went well, you confirm that. This is your new official validate partition. If something went wrong, you get back to the previous one, and your product is always operational. Definitely the most interesting update strategy in terms of robustness, but yeah, it costs storage because you have to split your flash into parts. That could be an issue for some customer. And implementation is also a little bit more complex than the other way. You have to be careful of having a robust strategy. You have to be sure how, for example, you validate that your system is correctly updated. For sure, you can consider that just when my system boot, I consider that it is working, but that's not true. Maybe your application will not be able to communicate with the cloud platform for the future update, or maybe something went wrong with a specific. So you have to define, and this is really specific to your use case, to your business application running on the equipment, how I can consider that my update is a success. And that's not so easy, to be honest. It really depends on a lot of conditions. So let's continue. Robustness is okay. Let's talk about security, because that's the word that is really, really important today. And you have two main strategies. I can say unsigned. I deliver a package, I accept all update package without checking anything. It's easy, does not require tool signing, PKI, certificate, private keys, but there is a big risk of corruption or patches not coming from you, or that's, in our today world, definitely too risky, but that's doable. The other side, you can sign your update image. What does that mean, sign? I will not get back to the theory of asymmetric key, hash, signatures, verification of the signature, but you will more or less need a private key or public key, sign your package, sign the hash of your package with your private key, and then validate it with your public key that is integrated into your equipment. You will have to be sure that this public key could not be compromised. You will have to be sure that your private key you are managing in your manufacturing, in your R&D, is safe and will be managed for a very long time. So that will probably bring the question about having a PKI, public certificating key infrastructure, which bring a lot of questions, not only about technical topic, because even building a PKI is just few OpenSSL commands, but managing that in a proper way is another story, where I can hide my key. Do I need an HSM? We have customers that just have a USB key and bring it to the bank, saying, okay, that's my private key, and they use it only when they are generating new project, new equipment, and generating a list of devices. But what's happened when I have multiple manufacturing that are deploying new firmware? That could be a big topic. So yes, sign is probably something mandatory, and the new regulation will probably make it more and more mandatory. But that's a big topic, and that needs specific knowledge, specific people, specific processes that you will have to implement in your company. Maybe just one insight we have seen, there is usually in your IT department already a PKI, because a Wi-Fi certificate, because of a user authentication, because there is probably somewhere in your organization already a guys, probably on the IT side, I'm sorry, we'll have to talk about with this guy, but that are this knowledge and are able to generate certificate and manage the secret and so on. So create link between OT, IT, between the R&D team and the IT could bring you very interesting information about maybe we already manage that. Yeah, the main concept is definitely complexity key management. And okay, I would like to add in, here I'm talking about the package you're delivering for the update, but there is something that is named secure boot that you may already know, the concept of secure boot. When you are starting your equipment, the firmware is validated by the ROM code, the internal part, with a dedicated key that is fused into your processors, which is not able to compromise. So there is a dedicated process to implement secure boot. The concept is my ROM code identify my bootloader, my bootloader identify, authenticate my kernel authenticate my application and my partition. So you are, if you correctly implement your secure boot system, in fact you don't care about sign or unsign your update system, because even if somebody tries to push a package in your equipment, they will not be able to have a sign application deployed on your equipment. That means when the secure boot will operate during the update, the next reboot, the package will be refused because it will not be signed by your private key that you are the only to know. So secure boot probably removes this question. You can implement such type of sign update just to avoid applying everything in your system, but that's answer a lot of questions. And on top of that, secure boot is definitely the best approach to deploy a new equipment, a software on an equipment. So you also will need to take information about that if you not already have. I continue. So we have seen the 4 different solutions. Here I'll just make a focus on some technologies we are deploying. It's more focused on Linux because I'm more specialized in Linux. But you have different approach, different stack, open source with commercial approach. You have solutions that deploy full package, files. OS3, for example, is a system that is able to manage at a differential update at your file system level by doing like a Git repository with you commit some files and you deploy only the patch and the diff. You have a lot of different solutions. today we will have Josef that will talk a little bit more about Mender, which is one of the solutions. Mender, we are integrating it into our software solution. So if you want to say more.
If I want to say more, yeah, I would love to say more. Thanks for having me. So, yes, Mender is, from all the things that you have just mentioned, is the only end-to-end solution. And we will just do Mender in 3 minutes probably, or 4 minutes and 2 slides. So I will go really, really fast. I won't even introduce myself. We have one problem, because the show is almost over. There won't be a lot of discussion after this. So I've noted my contacts here. I'm super easy to reach out. Just shoot me a mail, tweet, whatever. You will find me, and I'm really easy to get in touch with. We can have a call, coffee, whatever. And here we go. So Mender is an end-to-end solution in such that it provides both the client on the device as well as the management server. This means we can control most technical aspects that are only possible if you need an integrated approach. So, I mean, the client, for example, can do a lot of crazy things depending on which client you use. You can do all of the technical approaches for deploying a specific kind of update that Pierre just mentioned. But if your remote management backend just knows about file system images, then the fancy client won't help you. On the other hand, if you have a remote backend that can do all kinds of super advanced fleet management, but your client only knows about a binary blob, it's again not helpful. So that's what we do. We provide one solution that is completely matched to give the best possible functionality across the whole structure. By default, we promote the AB solution because that's the most robust. When something goes wrong, you can always go back to the last known good setting. I say by default because it's not necessary. If you really want to use Mender just as a client to do something else, you can definitely do that. Why can you do that? Because Mender, the client is open source, Apache licensed. The backend is also available in an open source Apache licensed package. So you can just self-host, run, be happy, and never tell us. You're invited to do that. So, next 2 minutes, I told you, if you have a client that can do all those crazy things and the management backend does not support it, then you're out of luck. So, if you use Mender, then you are hopefully lucky because we have a very, very flexible system of whatever you want to deploy. I'm pretty sure that we can make sure it ends up on the right device. I always say, in the end, we are a software logistics company. Just like the Deutsche Post is a letter or a parcel logistics company. They don't really care what is in your parcel as long as it is legal. Oh. There are files that I think are illegal, like hip-hop music, but if you want to deploy them, I'm good with that. So, I always say, whatever you can put into a file, we can deploy it. It can be complete operating system updates, just as the AB scheme we have at the top, but you can have a specialized handler that covers all kinds of crazy appliances. We provide a couple of blueprints or examples, like you want to roll out just a single file, you want to roll out a Docker container, you want to roll out Docker Compose-based microservice structure, you want to roll out something on K3s, whatever, then we've got you covered. And that's a very common case if you have a more fine-grained approach, like just managing an application, just deploying an ML model, just deploying navigation assets, something like that. Then you create a custom update module that provides you with exactly the artifact format and the handling flow that you need. And we will make sure that this flow gets exactly the data that it should put on your device. And with that, I think I have taken up my 4 minutes of Mender for you. I'm pretty hoarse on the voice. I hope you can apologize that. And I hand back to Pierre. Thank you very much.
Thank you, Josef, for this explanation. So yeah, Mender is an interesting technology for this update. So you will have now to define your update strategy. So we have seen different ways to do that. Distribution, content, robustness, security, and you will have to select your different preferred way, mandatory way, and at the end, create your update solution with, for example, this so good technology coming from Mender. At the embedded kit, we are providing a Linux toolkit, which is a Linux distribution based on Yocto that pre-integrate the Mender technology, but also another package which is named Software Update. And we have made some choice. So if you want to discuss about this choice, I will be happy. But distribution, you can do whatever you want. Really makes sense to have a level of granularity. Regarding the content, we define that in a first approach, having a partition level is a good compromise between files and full binary. Robustness is AB. This is maybe not a question. And you can do whatever you want in terms of security, but we are providing on top of this secure update solution, we are providing all the content for being able to deploy a Linux distribution on your embedded equipment. So we pre-integrate the secure boot, we pre-integrate the continuous integration, we pre-integrate a set of features that make your deployment of your Linux solution as easy as possible, and we pre-integrate it with a lot of different hardware coming from different sub makers and different silicon vendors. So that's it for us today. If you have any question, we will be happy to discuss with you. I think we now have time, everything is finished. So thanks a lot, and if you have any question, feel free.